Now let's do a right tail problem. So a company, let's say Target, believes 38% of shoppers use digital coupons. That's true of the population. That's what they believe, that the population is 0.38, that's how many people use digital coupons. Now, if we took a random sample of 140 shoppers, we want to find the probability that more than 44% will use digital coupons. So we want to know, if we take this sample, what is the chance that this is true in the sample, which means that's p hat. P hat is our sample proportion we're analyzing. P is what we think is true of everyone, 38% of all shoppers. P hat is what we are trying to predict will happen in the sample. So since we were taking a sample of 140 shoppers, and that's the proportion we're analyzing within the sample, that makes it P hat. So our regular P will go in the middle, just like the mean in our other problems. And we want to figure out, if we took a random sample, what is the chance that actually 44% of them are going to use, or more are going to use their coupons. So as we can see, this is a right tail problem. We're still going to need to find our z-score. And before we can actually do a z-score and go get the right tail, you should notice this problem doesn't give you the standard deviation you need. So we have to know, to find the standard deviation, when we're talking about a population, we're going to take P. Oops, sorry, let me give myself some more space. We're going to take the population proportion times 1 minus the population proportion, divide it by the sample, and we'll take the square root. So to get the standard deviation that we need for our calculation, I'm going to take the population proportion of 0.38 times 1 minus the population proportion, divided by the sample size of 140, all of which is underneath the square root. And now I'm going to go type that into Desmos. 1 minus 0.38 divided by 140. And we are going to get a standard deviation of 0.0410 for this problem. And that's what we'll use to get our z-score. So now to get the z-score, we're going to take p hat minus what we think is true of the population. So it's always p hat minus p over the standard deviation we just calculated. Okay. 0.44 minus 0.38 divided by 0.0410. And we will see a z-score of 1.4634. And as you can see, this is a right tail problem. So when I go to my spreadsheet, I just want to know the right tail probability, the chance that 44% or more will actually use their coupons. So 1.4634. Let me adjust this. 1.4634, right? Let me double check that. 1.4634. Okay, great. Oh, that did not save, of course. 1.4634. Let me hit the check mark and then double check that. Oh, why didn't that update? Sorry, let me just see what's going on here. There we go. 1.4634. Let me double check that the formula updated. It did, but I don't want the left tail for this problem. I want the right tail. So I'm going to go over, well, let me just do the whole process just in case we're confused. So I have the z-score I want. I'm going to go grab the left tail, norm.s.dist, and I'll put the z-score there. But this problem just wants the right tail. So that's gonna, all I need to do is go equal 1 minus, click on the left tail, and that's our answer, 0.072. 0.072. So a 7.2% chance that if we took a sample of 140 people, that more than 44% of that sample would actually use their coupons.